Alright, back again for another edition of Draft Physics, the do-over and such. Only one comment, so I think we'll do a Ken Wheeler video and try not to react to the rhetoric and try to find some sort of Rosetta Stone of communication, some sort of way of interpreting what's being said, or some concept, or some vague idea of a concept. But there's just clearly wrong statements, and so I have to state they're clearly wrong. They need to be reworded, restated, because they're wrong. Anyway, Mountain Goat Joe. Hi, DraftScience. I know this can and maybe should be interpreted or perceived as just nonsense that doesn't contribute to a damn thing. Well, you're making a humble beginning anyway. But here I am. I'm here to say thank you for sharing your knowledge candidly, freely, and saving the self-deprecation for tricksters. I don't know if I'm not self-deprecating. I mean, no. I mean, I don't say I'm stupid, because I'm not, but yeah, I have my problems. I have my issues. I have personality aspects that are not conducive to this project. No doubt about it. I am disabled from a car crash because a down stop sign. Well, it's probably more complicated than just the sign, but yes, people just aren't careful enough. It's just the truth. I see it every day. People are just sitting there saying, I'm going to buy a ticket into a dumbass, stupid lottery. And it's just so stupid. Anyway, I'm 32 years old and I'm using my imbalances to create technological concepts with the goal of enhancing tools. There are a few tools that need enhancing, frankly. Usually just a leverage issue. Make the handles longer, damn it. Make the shaft of the screwdriver longer. I mean, these short screwdrivers are... yes, they have their place. I just mean, sometimes screws are inside plastic holes and blah, blah, blah. Anyway. Also, innovative approaches to how to use tools. Yeah, it'd be nice to have some tools that you could just stick to your forehead, It's just a holding tool or something, a hat that holds your stuff, something. My direction in time was separated and diverted, weren't we all? And now I'm using shitty CAD software currently. Yes, well, whatever you use, you have to learn how to use it, which is part of the bitch. But I am saving for SolidWorks. Yeah, I just don't know if I would have the patience to figure out how to get anything out of the software. I just don't have the time. The lessons you offer have directly empowered my shortcomings. Okay. Frankly, it's empowered me thinking over time, living and learning. It gets so much less complicated. Once you get their crap out of your head and get something rational in your head, you can start seeing. It's like the Matrix or something. You start seeing the Matrix, You start being able to read the code. I respect you very much and appreciate all aspects of your videos. Well, all aspects, I don't know. It is my intention to reach out to you on a professional collaborative basis. I don't really do anything professionally, but okay. When I achieve conceptual viability. Okay. If we can have shared purposes, great. I hope I can work with you someday. Well, we'll see what happens. Thank you, DraftScience. Well, it's just very nice, and sorry, and somebody maybe should go to your channel and see if they can get you some software and blah blah blah. I'd like to help, but I got my own limitations. So anyway, Yeah, I feel good that you've got the right attitude. You know, you can't. Two wrongs don't make a right kind of thing or whatever, you know. So you got to make the best of your circumstances. So way to go for doing that and such, and endeavor to persevere. Right, that's all we can do. Just endeavor to persevere. It's a great line from Outlaw Josie Wales. One of the only things me and the Amazing Atheist agree on is probably one of the greatest movies ever made. But anyway, just saying. I mean, it's not the good, bad, and the ugly, and it's not, it's not a lot of things, but it's, it's a good movie. Unlike that Unforgiven crap, it's just a stinker. I mean, watchable, but a stinker. When for the last 5 minutes, that movie would have been just such a pile of crap. Anyway, where the fuck was it? Don't you be cutting up no horse. I'll kill you, I'll kill your kids, I'll kill your dog. Yeah, great line. Anyway, moving on. To what? Words. Let's do those first. Alright, now in communicating, Bill Gates is sort of doing this. You have to start with something. So you start with some understanding of what we're trying to do. And as I've sort of pointed out, if you don't believe in cause and effect and you think there's angels and all that, well, let's just not bother, right? Forget about it. And what there is in the universe is stuff moving. And what happens is one thing moving transfers its movement to some other thing moving that will be now moving. And they move in directions. And they land in locations. And they hit things. And that's just a fact. Things hit things. Now, whether you want to call the thing a wave, or you want to call it a lump, or a clump, or a bump, should that really get in our way? I mean, Ken Wheeler just keeps saying there's no such thing as gravity, and there's no such thing as attraction. Well, obviously those phenomenon exist. So why say something as stupid as there's no such thing as? Now, if you want to say their explanation of what the mechanism is incorrect, fine, but don't pretend there's no such thing. We have to use a word to describe the different kinds of things that are happening. You have to say, well, you can say, oh, there's no such thing as dogs, technically. Well, you still have to call it something because it's different than a cat. It's so you gotta call it something. And maybe this is what it's all about. It's just he wants to make sure our language is all in some sort of wave language. So this whole wave particle thing, I mean, it really is. We're just trying to say, okay, there's a transmission, an emission, radiation, reflections. And I would argue that what you're sort of doing is exchanging. There's a lot of exchanges going on. And that's all we're really talking about. So, something that's irritating something over here ends up irritating something over here. And the irritation travels through space from one thing to another thing. The movement. I would argue more complexly what's happening is that energy is being trapped and released, and so when something interacts, it's really just making an exchange for some sort of new irritation, and it gives back an old irritation. Okay, so it's all just exchanges, and so you're really just exchanging using this free stuff to exchange something some petty resentment you have, and then you release it and make it free, and then it hits somebody else like a virus and infects them, and then they release it and free it, and just that kind of thing. So yeah, Ken Miller says things like there's no such thing as gravity, or people talk about zero gravity, and well, that's really not technically true. It's not that gravity as a force stops, is that what we're really talking about is a balance, that things are equalized. And you can sort of see that in Maxwell's charge equations, that places where there's two things creating fields of energy, and there's zero energy technically in some location that's clearly being hit by both. It's clearly not zero energy, it's just balanced, and that's it. There's as much yin as there is yang, but there's no absence of yin yang. And I would argue if you really had zero gravity, you'd have zero matter, because the matter really is being held together technically by gravity in the form of magnetism. So again, some of this physics you can't avoid recognizing that these different theories have incompatible mechanisms, and it just makes conversation impossible. But I guess what I want to illustrate is Ken Wheeler's not doing any better, in the sense that conventional physics gives us this idiotic notion that something is spreading, like a wave, and it's going everywhere, when we know it lands in one location. Why are we falling for some notion that it goes everywhere but it lands in one location? I mean, does that make any sense at all? I mean, it really doesn't, that you could imagine making all of this stuff going through space in all these different places, and somehow all that gets retracted and forgotten when it lands in one location, and then you decide it was a straight path. I mean, it just doesn't make any sense. The straight path was what it was traveling. It wasn't what it creates once it whatever the stupid word they use is. I'll remember it later. Alright, so you got this idea of a ray of force versus a field of force, and there really should be some sort of recognition of the difference. When people talk about field theory, field of what? So it has to be field of something. And if it's going to be a field, then it's going to be lots of rays, in my opinion. You just can't play this game that the field is some amorphous, unconnected, unreal thing, when we know it always kind of lands as a ray. It lands as a point. It lands in one place. So why do we keep doing this? Why are we indulging language that just doesn't fit the evidence? And then force can only interact with matter. I mean, this one's something everybody should be able to agree with. We see it. Okay, you can't bend light with magnetism. You can't smash light into light. You can't do any of that stuff. And the only example we have of force affecting force is the photons being bent by gravity argument. And that one has such weak evidence that people should be willing to say, okay, that might be wrong and stupid. It might be a mistake. Because in every other circumstance, there's just no evidence I can make a force move a force. I have to have a piece of matter do the translating. It has to be there. It has to go through. The electricity has to interact with electrons. You can't just move the force unless it's of photons, unless it's laser beams, unless it's in some other form. So, radio waves, whatever. So yeah, that's probably enough of just getting to some of this language, and so then I'll try to interpret into reasonable speak what Ken Wheeler is saying. I'll make an effort, and I'll just point out that even though I'm making an effort, you just can't fix this crap. Alright, so he made two videos that were poor. The first one was debunking Einstein when he didn't debunk anything. So the argument's made that Einstein was validated by a couple of things. The stupid Eddington experiment and this prediction of time dilation, which a lot of people had already talked about. And first Einstein played with time dilation as caused by acceleration, which is a form of velocity, and then in the general theory pretty much pointed out how any velocity, whether through acceleration or some past acceleration, causes this effect. And as I've argued, it's just a mechanical consequence of movement. movement affects the thing that's moving. So when you have a velocity, it means there's stuff inside of you pushing you still. That's why you have a velocity. And that function of pushing you means that stuff that was doing other stuff can't do that anymore. So I use the analogy of somebody dancing as fast as they can, all right, and then I ask them to move left or right. Well, then they can't do the same number of dance steps. So there's a perception that they've slowed down when they haven't. They've just had to use some time to move. And the same thing happens to physical objects. When you move them, their functions slow down in the sense that they have to take some time to do the moving process. So whatever movement they were doing in the matter takes longer because they have to travel a longer path. If you're doing a circle and I force the circle to move, you will trace more space, which means you can't do it as quickly. You can't get from here to there as quickly. All right. And if you do get there as quickly, it means that your functions have to be compromised. You have to do less circles. All right, anyway. And so there was no explanation of how there isn't the effect of time dilation. And there was really just no argument explaining exactly how Dr. Eulig proved Einstein's relativity to be the non-cause. So you can argue about what causes time dilation, but you can't really argue about its existence, and you can't really say that Einstein's theory doesn't predict it, because it does. So that's all kind of bullshit. So if you're going to make the argument, you have to prove there is no time dilation, or you have to prove what the real cause is. And there was no example of the real cause in his video. Now, I think it is valid to also point out that Einstein's mathematics won't produce an exact number, that it's not as precise as it should be if it's true. They have to put in constants for, variability of whatever atomic thing they are using as a clock, and they have to fiddle with the numbers a bit. And technically, you could argue they shouldn't really have to. But anyway, that's a very tangential. But anyway, so he did a 10-minute video basically saying it's proven, but that it's not the cause of the effect, and yet there was no evidence presented demonstrating any proof. So that was just sort of bullshit. And so this video was just bullshit. So let's play it. Ether and ultimate reality as against atomism. So again, even using a word like atomism, when we know there's the concept of an atom and an element. He holds up different elements, neodymium and whatever his favorite one to melt is. And so what is he? Why argue with atomism? To some extent, there is atomism. So why are you playing this game? This is a stupid semantics game, and apparently he gets rewarded for it because I guess people really just want to, they want to declare everything wrong, and they don't have anything rational right to replace it with. They're just wrongers. They're just sledgehammer people. They don't like anybody else being right, so they're going to make this fat guy right for some reason, which I just can't understand. No, can't do it. Can't understand. And such. Well, thank you, YouTube. Oh, finally. Well, not really. Oh, we have to do the little ad first. Yeah. Ugh, pathetic. So, browser is frozen. Great. Eef. It's kind of a big freeze. Yes, you're slowing down my browser. You're blowing up my frickin' computer. Stop it, maybe. See how that works. Hey, this is getting ugly. Alright, the last time this did that, it still was recording, so... but I don't know how to fix it without getting this to pause, which I can't do at the moment. So, my plan will be... My plan. Try closing that. What the hell is this stupid icon? Huh. Alright, well, when I get a good chance to pause, I shall do so. Let's try Control R. And we'll see what happens. Damn it. I don't want to start the video over. Okay, so it killed that video. Did it pause? So I'll pause it and then. Alright, it won't work. Come on. There you go. Pause video. Okay. I'll see if I can get the video playing without this. Alright, we seem to be back and hopefully it's working better, but I can only hope.
Okay. I can talk about field theory until the cows come home. I don't know who wants to listen.
Yeah, well, there are apparently 8,000 people, 674 thumbs up to 47 thumbs down, and it's just gibberish. It is just that. So field theory, I don't know if this is a replacement for, again, just sort of using some other kind of language. We're just talking about the transfer of momentum or movement or states. And the state change takes place through these fields. They call them fields, but they're always moving the speed of light, and they're kind of this idea of a kind of radiation. You radiate it, something else gets hit by the radiation, and it has an effect. Now, I'd argue that the differences between the radiation isn't all that dramatic. We're just talking about two kinds, electron-proton radiation, and you can send it at a frequency, but that's about it. Not all that much variety.
You go really, really deep down the rabbit hole if you want to.
Yeah, I don't think there's you go down the rabbit hole and you just find the simpler and simpler causes, mechanisms, devices, and that's sort of what we should be after. Now, if you people believe in an ether, okay, well then you sort of have to make it out of something. And it doesn't really, I don't really care, but you'd have to have some idea of what it does. And if it contracts and expands, well, then you have a conservation problem. Because there's no real evidence of the idea of something slowing down and then speeding back up. Or, what's the right word? No mechanism for that. It should speed up going in and slow down going out, and that's not how it works. And then the other geometry problem I brought up before, if you make your ether out of little bits, well then you have a checkerboard problem. If it's a checkerboard with prearranged roads, then things can't fly any vector. And there's just no evidence that things are limited to where they can land on something. They can land anywhere. And diagonals and square lines don't give you enough choices. So if you start making it out of some sort of geometry, you're going to have a limited number of vectors.
By the way, my prior video in disproving relativity.
Yeah, so yes, no disproof, no evidence provided at all, nothing. Just statements. We did it. That's it. Somehow we proved that relativity isn't the cause of time dilation, even though they didn't explain what was.
A la the article of Dr. Oli Fomenko, PhD doctorate of mathematics and physics.
So he'll piss on mathematicians all over the place as if they're useless, and then he cites it as an authority now because he has a PhD in, you know, whatever he calls mathematics when he wants to insult it.
And here are some of his extremely heavy-handed, math-laden books. And this one's my favorite. My other copy got so worn out that it fell apart. This is Causality.
So, you know, the simple thing to do is to pull out some little perfect pearls out of the book, you know, little great pearls of wisdom, and show them to us and demonstrate how, wow, that's just so impressive. But he doesn't do any of that. He just says it's really, really great. Says Ken.
Electromagnetic Induction and Gravitation. It's a brilliant book everybody should actually get. I know there's a digital copy out there somewhere. I have it. I have a digital copy of it. Brilliant scientist. Let's actually talk about, it's the easiest way to debate stupid people and stupid ideas is specifically quantum. And of course quantum...
So he doesn't debate any of this stuff, so let's understand again. He doesn't take on any challenge. He doesn't subject himself to questioning. He wants to sit there and just ridicule other people with freedom, without any implication that you should be likewise treated with just as much disrespect, that the same ad hominem should be used against you, and that you know, because you know, and again, where you can question their statements without having to hear their replies, and you know, that's just cowardly.
Doesn't refer to anything whatsoever. Nikola Tesla said that you can be both extremely intelligent and insane. A lot of
yeah, well, he was hardly a case himself, right? He's not exactly somebody who's a profile in reasonability. His life was sort of an example of a semi-unreasonable person. So, you know, come on. You know, he's going to give people psychiatric evaluations? I'm sorry. The guy spent the last 30 years of his life taking care of pigeons. You know, not a bad thing to do, but I'm just saying. Street pigeons.
Scientists, he said, are deep thinkers, but they can't think clearly. Specifically, I think Tesla's quote is that...
So he doesn't have specifics, so that's another thing where, you know, if you're going to quote people, it'd be really a sign of respect is to accurately quote them, especially when there's so much of that quote mining going on and so much crap where you know, people are paraphrased into saying what they never said, and you're just, you know, a horrible example. You think you're doing a tribute to Tesla by bastardizing his words?
You to think clearly, you have to be able to think clearly. It's not just about thinking deeply. You can think deeply and be incredibly insane. This, of course, is the genesis for quantum.
So again, this isn't about insanity. So this hyperbole. So again, all this, you know, all these people rewarding somebody for just this poorest type of rhetoric, just these stupid ad hominem attacks. Clearly, this isn't about insanity. It's about mistakes. Okay, it's about mistakes in judgment. So I think it's reasonable to argue that some of these scientists are frickin' adolescents. Okay, that. There's a problem of adolescent scientists. They keep saying how, well, these, you know, your career is done in physics when you hit 27. There's, you know, no old physicists do anything worthwhile. You know, it's a general statement. But in some sense you could say, okay, there's a grain of truth in this, because clearly it's only these people who still have childish fantasies who can make up this crap, and who have the will to make up crap. So that's why the crap runs, is because it's a crap engine built on youthful enthusiasm for making up crap. But it's just mistakes. It's errors. So point out the errors and quit with all this ad hominem crap.
If you start with a faulty premise and using retroduction, it's easy to destroy quantum and particle physics.
Well, if it was so easy, then you'd be doing a better job. You know, I mean, it's obviously not that easy to destroy, because it's this complex theory that's morphs all the time. It's always changing and adapting to any new piece of evidence or any new kind of mathematical gimmick. It is latent in all kinds of complex math to say yes, it's correct, because we have formulas that we have engineered to come up with right answers, but we don't even know what's in them. Again, many physicists will admit they don't know how Einstein's field equations work. They don't even know what some of the things in it are doing. It's like you going to screw a picture frame thing onto the wall or something, and the instructions say, go to the dishwasher, and say there's no place like home 3 times, and then screw the screw in. And you're saying, how could that possibly be related to this over here? There's no connection. But somehow it works in the end. It doesn't mean that going to the dishwasher works. It just means that they can write a formula that has all kinds of crappy shit in it, and yes, it still comes up with the right answer, but there's crap in it. It's like 2 plus 2 plus walk to the dishwasher and say there's no place like home equals 4. Yeah, it probably still does.
Not that I don't believe in particles. There is one fundamental particle, of course.
All right, so that would have been nice. One fundamental particle. So let's start with that. So let's explain to me how you make charge out of one fundamental particle. Explain to me how you create all the tension that you need to hold an atom together out of one particle. So explain a few things with this, how this one particle does all these things. Draw me a picture. Start with one particle and then draw me the picture of the one particle making the universe.
Just one, and one only. But destroying it is extremely easy. If you actually start off with a faulty premise, then everything that's after it, of course, is bullshit.
Right, and the same thing could be done to the statement you make about how things work. Light is a coaxial cable. Coaxial cables are just a demonstration of a complete circuit. Okay, there's the plus and the minus. One's on the shielding and one's on the core. How is light anything like that? Explain it to me.
Specifically, and here's one prime example when we talk about the double slit experiment. And of course that is a simple exercise in constructive and destructive interference.
So again, it's not a simple exercise, because first off, the pattern doesn't match that mathematically correctly, in the sense that if you do it with electrons, you get a different looking pattern than you get it when you do it with photons. Photons don't do what is mathematically obligated to do, which is create your wave of light distribution. The distribution isn't gradual. It's very bar-like. Then with multi-slits, clearly there's images sent to the different locations. So wave interference will account for where the images are, but it won't account for the fact that they're images, because the constructive and destructive should be destroying the image. You shouldn't be able to see an image if you've destroyed some photons and multiplied some other photons. If you've done wave interference, you can't transmit something accurately. So there's all kinds of questions, again, that you don't answer. You just evade them. All kinds of debunks of your theory that you're too cowardly to accept and respond to.
You actually set up a phase disparity of the ether perturbation. That's all.
So he's buying into their theory. He's basically saying they're correct, that the single photon somehow breaks into multiple photons, and that nonsense somehow makes sense. So you have a single slit, and somehow that creates 2 photons that interfere with each other. Then you have 2 slits, and somehow that only creates 2 photons that interfere with each other. Not 4, just 2. And that makes sense to you logically. It doesn't make any sense to me logically.
Light is, of course, light is a coaxial circuit,
So a coaxial circuit, transverse something or other, right? How is it doing any of that? It goes from point A to point B. The irritation, the transmission, the stuff, the movement, the momentum travels from one point to another point in space. And you want to argue about how it travels, but can we agree that that's what happened? Okay, that momentum travels from one place where the momentum was in the form of electricity or some other form, and it ends up landing somewhere where it causes more electricity or movement. Isn't that what's happening? Do we really worry about how it gets from point A to point B? Can't we just argue about the fact that it's a truth that it goes from point A to point B? And then we can have this argument about, well, you're saying it's dispersed over the entirety of space to get to point B? That it doesn't travel a straight line? Or a line? What's your theory? How did it get there? Did it wave there? Did it perturbate all of space to get there? I mean, there's just no distinction. He makes no distinctions between the slit experiments done with single photons and give us an explanation for how the single photon encounters the experiment.
Electrical magnetic, longitudinal dielectric pulse perturbations.
So again, this isn't telling me anything. Longitudinal dielectric pulse perturbations. Well, guess what? Longitudinal, he's almost arguing it's a straight line like a laser. How does that create wave interference? How does something, a little longitudinal pulse perturbation, how does that encounter a single slit and create two waves that interfere with each other? What's your explanation? Do you have an explanation? Are you going to say Huygens? Because that's clearly bullshit.
But if you actually start off with a false premise, i.e. a la wave-particle duality, and
yes, well, again, throw that out then. Let's get rid of the premise and let's try to use language that makes more sense. So yes, wave-particle duality is retarded. But you're just attempting to say it's waves, and you've clearly said it in spite of the fact that you say there's no such thing as a wave. You're clearly dependent on it. You just pointed out how it's wave interference. You've just said it. If you're going to say it's a phase interference that causes patterns, then you have to account for how the phases interfere with each other. How is it possible for them to do that? And they can't do it as laser beams. They can't do it as straight lines.
And that light has a speed. Nothing that you could actually conclude about the double slit experiments is sensible, logical, and
nothing you could conclude based on the double slit is sensible. No, you're supposed to be arguing their theory, and you should just say everything they say is garbage. Well, they're saying exactly what you're saying, that it's wave interference, that it's a phase interference pattern. So where's the distinction? You're tearing down the very theory you're dependent on.
You've already started off with crazy presuppositions and concepts in your head before assuming any conclusions.
So again, this is just so kind of idiotic. Sorry. Clearly, they don't talk about any of these experiments in any sense. Do they talk about the mechanics of it, how it happens, in any way particle? They completely blow up the idea of particle. They compare it to water waves, they show wave fronts, even though it's a single photon. There's no particle in any cause that they demonstrate to be the effect. And all they say is the effect is a particle. All they say, it lands like a particle, but it works like a wave. That's what they're saying. So 99% of what they're saying completely agrees with you, and yet you're trying to trash the theory. And all you're doing is trashing the fact that, well, they reluctantly have to acknowledge that when they send single photons in, it's a single photon goes in and a single photon lands in a location, and there's just absolutely nothing else happening. Everything else is invisible, except for the fact that they know a photon left and they know a photon landed in a location. And that logically, oh yeah, that sort of looks like it should be a straight line, but it's not. You know, that somehow it traveled linear paths. That it's not wave interference, that it's a refraction that causes the effect.
in testing the double slit experiment or the conclusions made thereafter. Specifically, there's no such thing as a wave.
So again, this, why say there's no such thing as a wave when the word was invented to describe the phenomenon of pressure moving? Okay, and that's exactly what it's there to describe. Now, clearly, the first use of the word was to probably describe water waves. This idea of this pressure, moving and landing. And we know that these other things can move and land. It's like sound, and different things can move and land through a medium. And that's essentially what wave was supposed to, probably should have stayed as, is some kind of thing that happens in mediums. Now, fine, you want to say there's a medium. Well, then you can't use this linear word. You can't use this idea that it's only moving in one vector. So explain to me how the wave goes everywhere, but only lands in one location. Explain that part. How the perturbation does that.
Light is not a particle, and light doesn't travel. What do you mean light?
So again, it's just kind of stupid. Okay, fine. Light's not a particle. It's a vibration through dominoes. Okay, so explain how the dominoes are set up. Because we know the path isn't just one domino that you're flipping. You're flipping all the dominoes, okay, in a whole big arc. And then you're saying, but when it lands, the only domino that falls is this one. Okay, all the other dominoes stop falling. They never get to a target. They never get to a termination. They just stop flipping by some mechanism. And you're saying that's what should make sense to people. It doesn't make any sense to me.
Does it travel? Sure it does. No, if you think light is actually propagating from point A to point B, something...
Propagating from point A to point B. So he uses his own language and says, if you think it's doing that, you're an idiot. Well, of course that's what it's doing.
Is moving from point A to point B, then of course you're a fool.
So obviously stuff moves in the sense that the pressure moves. The idea of being pushed moves. And it's all just a little push. I push the guy in front of me, he pushes the guy in front of him, he pushes the guy in front of him. So there is movement moving, right? The movement goes from being here, where I hit my domino, and the domino hitting goes to here, and then it goes to here, and then it goes over there, and over there, and over there. So clearly the movement moves. Now, that's what they believe, that's what I believe, that's what you believe. So why argue the existence of the movement moving?
It would be equally stupid to think that someone in a large swimming pool, just one person, for example, is like flapping their arms for...
So he's using this example 7 million times as if it proves something. It's not an example of a particle failing to work. Okay? So he's trying to destroy the concept of a wave, and that's the very thing he's dependent on. So it just doesn't make any sense. Why make this argument? Clearly your hand's moving. If you're moving in a medium full of dominoes, your moving hand will cause dominoes to fall. Yeah. But I could also equally make the argument that the movement of your hand sloughs off elements of what your hand was, and those elements fly somewhere. But who cares? We should both agree that movement here creates a thing called a force. The force moves to somebody else and he gets hit, even though I didn't directly hit him. I pushed a force at him. Like moving a magnet.
Authentically, right? And creating waves, of course. Waves of what? Waves of water. Is the person emitting anything? No, absolutely nothing is being emitted by the person.
Right, they're moving. Now, the argument is that in your world, no movement can take place without you disturbing the ether. So clearly they're disturbing the ether by moving. Now, I would argue that no, all movement doesn't create a field, okay? But all movement has to be caused by one. A force has to act on something for it to move. There's a little force inside of me, all over the place inside of me. And when my hand moves, there's actual matter moving in my arm, in my muscles, in all kinds of places to force my hand to move. It's forced to move. There's a force.
And at all. However, a disturbance is being made. The release of energy actually burning calories.
Yes, disturbance. Movement. Movement transferred from one place to another. Velocity transferred. Momentum transferred. Could we agree on the concept that all we're really trying to describe in the universe, what's taking place, is momentum, movement, is being transferred from one place to another place. Sometimes very directly and obviously, sometimes not so obvious in the fact that we can't see the little bits that are doing the actual transferring. And you want to have a stupid argument about whether it's a particle or a wave. I just want to have an argument about whether it travels straight lines or whether it travels in some dopey way where it goes to a bunch of places where it never lands. I'm saying there are no roads to nowhere made and then erased. That's just nonsense. And you believe that nonsense.
To flap your arms in the middle of a pool or the ocean, right? And of course you disturb the waves. You actually disturb the medium. The medium, of course, in this case being the ether. Let's get on to the ether.
Yeah, you won't explain the ether. So again, you just call it counter space. You'll call it some other word that doesn't make any sense, but you won't explain what this ether is. So apparently the ether is made of just one particle. As he said before, there's only one thing in the universe, one particle. And so he says there's no particles, but he says there are particles because there are particles that make up the ether. And now I just want to understand how something moves here, jiggles, and somehow it moves all these particles, but when it lands, it only lands where one particle was. Explain how that's possible.
Here directly in just a second, but of course when we talk about the wave-particle duality that scientists love to talk about, or specifically the dual slit experiment, they all begin with the fallacious presuppositions, in this case a trinity of fallacious concepts and presuppositions which are all incorrect.
So there's three wrong assumptions. So all they're doing is basically saying it's a wave, clearly. They're clearly saying it. Now, even though Feynman said, no, it's not a wave. But he was just a mathematician, right? And you don't have any respect for them. You know, he's the guy who said, just do the math.
Such thing as a wave. Light is not a particle. And light does not move. So if you're actually able...
So again, this idea that light doesn't move when the definition of light is something that goes from point A to point B. It doesn't exist if it's not going somewhere. So it's not starting here and finishing there. So the semantics of this argument is just so convoluted and stupid. And you're just saying, how can these people keep rewarding language this ignorant? I mean, it has no consistency. It makes absolutely no sense at all to say these stupid things. The fact is, it either travels a straight line or it's a wave of something, and the wave disappears. It goes places where it never lands. It goes there in secret. Okay? And it's never discovered that it went there, like some kind of Sasquatch. It's there, but we can't find it.
To erase that out of your head and actually think correctly and understand what a field is. Of course, a field is an ether perturbation modality.
An ether perturbation modality. Then that's what we're talking about. What's the modality? You say the single thing makes a vibration. The vibration goes everywhere, and yet it only lands, that is the momentum, the strength of the vibration, only lands in one location. And I'm just asking the simple question, how does that make sense? How did you flip all those dominoes? Where did the energy come from to do it? How does a single little thing turn into a multiple of things and then turn back into a single thing?
Just like ice, water, and steam are all different pressure and temperature modalities of one and the same thing, right?
Right. So we know that they're not one in the same thing, but you know the geometry of an atom is incredibly important to its properties. So fundamentally, the water molecule in its standard shape is different than if we stretch the two electrons further apart, or we connect the oxygen atoms in an octagon, or we connect them in some other geometry. Geometry is everything. It's the difference between carbon being graphite and carbon being a diamond. Huge difference in its properties. So it's kind of nonsensical to say it's the same thing but different. That's baby talk.
Okay, water. What's the difference between ice, water, and steam? They're all the same thing. They're different expressions of one and the same thing, i.e. the water molecule, due to pressure and temperature.
Well, it's, obviously, and that's the whole point. So, but why make this distinction? We know it still is made of the elements that make up a water molecule. So you can't turn it into some other molecule. Not without doing something very extreme to it to turn into another element. But why make this argument?
All ether modality expressions, both dielectric, magnetic, electrical, and
so dielectric, which there's no description of any such thing as dielectricity. So there's no dielectric except for a form of matter. I mean, it's just nonsense.
Gravitational are, of course, all one and the same thing. It's the exact same.
So dielectric, he said the word dielectric. A dielectric isn't a form of force. It's not a form of energy. A dielectric is a substance.
Difference between talking about ice, water, and steam. Ultimately, there's no such thing as gravity. Gravity is a misunderstanding of the nature.
So again, there's just no point in saying there's no such thing as gravity, because gravity is a word describing a phenomenon. The phenomenon is well known to exist, so there's just no point in saying there's no such thing as gravity. Again, you're just arguing with their theory. You're saying space isn't bent. I agree, space isn't bent. It's a silly answer. It's a real force, blah, 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 blah. But why, I mean, it'd be idiotic for me to say there's no such thing as gravity, because they're describing the cause wrong. No, the phenomenon of gravity still exists. Even if Einstein's wrong, gravity is still a word we're going to use. Gravity is not Einstein gravity. Gravity is gravity. This, the falling down thing. It's a real thing that really happens.
Of what gravity is, and the same thing that the idiots call magnetic attraction, which does not exist because...
So again, it's known to exist. It's a phenomenon. It's an event. Attraction is an event. It's not a thing. It's not a solid. It's not an object. You can't say it doesn't exist because the phenomenon clearly exists. Now, whether it's attraction or not, yes, I agree. Okay, it's not attraction, it's repulsion. But he'll also say that repulsion doesn't exist. So we clearly know that movement exists, and the movement towards it we call attraction, and the movement away from it we call repulsion. But clearly the movement exists, and all we really want, what physics is supposed to do, is tell you why does it move? What's moving it?
Attraction, i.e. Centripetal convergence, is a dielectric acceleration. There's no such thing as magnetic attraction.
Dielectric acceleration. This doesn't mean anything. Dielectrics are insulators. This has nothing to do with magnetism. Frankly, I mean, what does it mean? It doesn't mean anything. How does a rational person on planet Earth make that rationally make sense? That gibberish. What are you people saying you understand when he says that shit? How are you understanding that shit? It's shit. How are you eating it?
The distinction, of course, is the exact same difference between a 5-watt laser and a 5-watt light bulb. What's the difference between a 5-watt?
One of them disperses the energy it spreads it over a wide area, and one of them confines it to a small area. The difference is sunlight going through a lens. I didn't make more sun. I just concentrated the sun that was hitting 4 inches, and I turned it into sun hitting 1 millimeter. So I concentrated the light that was hitting 4 inches, 4-inch circle, and I concentrated into 1 millimeter. All of it. And so, yes, of course it burns. Same amount of energy. I didn't change the amount of energy.
Laser and a 5-watt light bulb. They're both EMR. They're both 5 watts. What's the distinction between a 5-watt laser and a 5-watt light bulb? So-called gravity is non-point source.
So again, he says it like it's a rhetorical question. The difference is one has the light focused to land in one location, and one spreads the light. Now, your argument is these photons are spreading anyway. Even when they're in the form of a laser, the photon isn't going in a straight line. It's waving here and over here. You think a laser is shooting waves. You can't have it both ways. You can't say, no, the laser beam's made of a bunch of lines of light, okay, rays of light, all concentrated, and then say, but when it goes into a slit, no, it's a wave, and then the wave splits into two. You can't do it. You can't have it both ways.
Mutual mass acceleration and so-called magnetic attraction, which does not exist at all. It's simply...
So again, he said it again. It clearly exists as a phenomenon.
Dielectric acceleration is points.
So dielectric acceleration and point source, and how does any of this mean anything? Draw it on a piece of paper, one of you devotees. Show me dielectric acceleration, point source, and show me how that is a coherent jumble of words.
Source. One is a multiplicative of the other.
What does that mean? One is a multiplicative of the other. So a lens focusing sunlight is multiplicativing something.
It's kind of like, a strong man can break, 10 sticks individually, of course, but if you actually put those 10 sticks together, the Roman fascia, even the strongest person on earth can't break it.
Yeah, well, that makes sense. I can lift 10 pounds really easy, but if I put 1,000 10-pound buckets somewhere, I can't pick that up. Sheesh.
Actually have not additive, but we have multiplicative factor here, and that, of course, is a distinction of what point source is. But getting on...
So again, a distinction of what point source is. So again, somebody explain. Show me this distinction. Show me where he articulated anything rational here. I can't believe you people keep defending this guy when this is gibberish. I'm honestly trying to understand, and you can't understand this. There's no grounding in any kind of sensible vocabulary. Things move, okay, got it. Jello can wobble, so we'll call that a perturbation. We'll call the ether jello, and it can have a wobble that'll go through it, like sound. And the wobble will go, well, how is the sound going from point A to point B, and is it spreading through all the jello? And once you've spread it into all the jello, how did you stop it from landing in all the other locations? How did the water wave heading for the shore end up just hitting one single grain of sand? How did it do that?
The ether. There's only the easiest way to destroy quantum, and of course quantum doesn't refer to anything at all. Modern scientists are not...
So we know it does refer to something, to the idea that there's this, just as you stated, that there's a single particle, that there's a single quanta, a Planck length, a smallness that you go no smaller than. And this is the quantity that things are exchanged in. So it's quarts of milk. It's not just any amount of milk. The milk comes in quarts. And so you can have 2 quarts, 3 quarts, 4 quarts, but you can't ever have a half a quart. That's what it means. That's how it's used in science. So why don't you just deal with that definition and explain how that's bullshit. How your ether does half of an ether particle.
Scientists in the Platonic Aristotelian,
or half of a perturbation, half of a domino flip.
Sense. What they are as mathematicians, they fundamentally believe the ultimate heresy is if you can't count it, then forget about it. So that...
Yeah, well, that's sort of important, but I mean, obviously we can't see a lot of stuff, so how the fuck could we possibly count it accurately? It's tiny, tiny, tiny stuff. We got to know we got to see 1,000,000 of them before we can tell what they're really doing. We can't see what the individual fish are doing. We can only see what the school of fish ends up doing over time. That kind of thing. So let's not play these kind of bullshit games.
We want to quantify everything. Quantum, quantity. the foundation for all cosmic.
So your theory, there is no accounting. You don't have to account for all the ether particles, the strength of a perturbation. It can be this much or it could be that much. It could be any amount of much. There's no strict rules. You can have more in than comes out. You know, energy conservation, who cares? Is that your attitude?
Mechanics and all field theory can only have two foundations. Talking about a house here. This is the house of quantum, and this is the house of rational, intelligent, wise people.
So again, the idea of the quantum is kind of well established by the evidence. So you want to argue that evidence, fine. Explain to me how the experiments are misinterpreted. You know, how they've got it wrong. Okay, that there isn't packets of energy and that there isn't a fact that it comes in clumps, as Feynman would say. Go ahead. Show me how it doesn't. Show me the experiment that illustrates it's not clumpy.
Like Plato, Plotinus, Nikola Tesla, James Clerk Maxwell.
Right, all these people born before some of the best experiments were ever performed. So when we have the best tools, these are guys who were still, you know, when they were doing the Olympics, they were still using a stopwatch. All right, that's the world they lived in. Stopwatch. You know, using their eyes to see who crossed the finish line first. That's the world they lived in.
This is the house that rationality built. And this is the house that crazy dumbasses built, i.e. quantum. One is built upon atomism.
So again, more just nonsense. Yes, you said there's only one particle. He says it right in the beginning of the video. There's only one particle. Isn't that atomism? How is that not atomism? You didn't say there's only one amorphous blob of sparkly goo-gah that can be any size and do anything. You said there's one particle. Shit.
And mutual interaction of particles, including especially. And this is not my view, because I'm about to say something that sounds completely ludicrous and crazy.
Right. So this is somehow an appealing argument. I'm going to say something ludicrous and crazy, why I call other people ludicrous and crazy for what they say that sounds ludicrous and crazy. So what's the point of this crap? Why don't you say something that doesn't sound ludicrous and crazy? Try that for a change. But then your ratings will go down. Because yes, people want ludicrous and crazy to replace ludicrous and crazy. They just want a different flavor. They don't like strawberry, they want banana.
But this is the actual belief system, and it is a belief system. It has no basis in reality, because if you reify...
So again, more of this basis in reality. Why don't we talk basis in evidence? Why don't we argue the evidence? Why don't you cite the evidence? Why don't you cite the experiments and explain how the experiments are being misinterpreted by others and how you have a correct interpretation? And do it without some sort of psi over pi over jai jargon.
Something that has never been the input or output of any experiment that ever existed and is purely conceptual with no...
So again, this is silly. I mean, clearly it has been the output of experiments, okay? It's a defined thing. Again, laser beams, different than lights. How are they different? Laser beam, the energy is confined to a small area through space. We can watch the laser beam traveling in the sense that we can take some of the photons and scatter them to our eyeball and see the laser beam, see where the rays are going. And you're telling me, no, those aren't rays of light. No. No, the light's really everywhere. No, it isn't.
Basis in reality, then it is a belief system. It's a freaking religion. Quantum physics.
And so is your counter theory. So I would agree that, and clearly you're basically confirming their theory. He's clearly saying it's wave interference. He's clearly arguing that somehow this stuff spreads everywhere even though it doesn't land everywhere. He's saying the same nonsense they're saying, so he's not disagreeing with them. He's saying exactly what they're saying. He's just saying it with word perturbation instead of travel. He's saying instead of clump, he's using perturbation. That's it. Quanta of energy. He doesn't like that. So instead, he's going to say a flip of the perturbating particle.
Literally. Okay, not kinda. Literally thinks that what goes on between magnets is the exchange of virtual photons. They call it.
So clearly, they're clearly saying literally that they're virtual, that they don't have the definition. They're just used as a placeholder for a force carrier because they don't have the force carrier. But they behave just like a photon. Now, that's what Maxwell said. Okay, that's what Rutherford, Faraday said. So, what are you arguing with? That's what they said. I'm sure Steinmetz would concede the same argument, that that's how it behaves. So, who are you arguing with? I don't know what Fido would say. What's his name again? Tesla. I don't know what he would say, but I think he'd clearly concede. Yeah, that's how it behaves.
Virtual particles, virtual photons, makes no difference. Virtual particles, not the basis of any experiment ever done. A completely asinine construct that's used to make equations balance out.
Discover the creep.
So, yes, the creepy. I guess I have to play the whole fucking ad.
Creamy texture of new classic Genovese pesto from Barilla.
It has no basis in reality. It's no different than saying leprechauns or unicorns.
And versus your Sasquatch. So what's the difference? You're not giving me any explanation for what perturbates, how it perturbates, and how it makes magnets move the way they move. Nothing.
Completely asinine. Completely asinine. By the way, something really, really important.
So he just says so. He doesn't show so. So he doesn't show us Maxwell's drawings of lines of force radiating from a charge and explain how their divergence creates the inverse square law, reduces their effect over distance. And he doesn't explain how those Maxwell drawings are ludicrous.
If people were actually to engage the dialectic and engage in Platonic retroduction, it would be very, very easy.
So we engage in this, whatever this process you call it. I would say there's only one thing. There's facts, and you use logic to put them together. So I can do that, whatever that is. I can do that. But where's your definition of a process? I don't see any process here. You say there's a single particle, then you say there's no particles. You say there's a single particle, then you say there's no quanta. Well, if there's a single particle of a single size and a single magnitude, then I guess that's quantum mechanics right there.
To quickly decipher the nature of fields, because at the center of a magnet, when you actually stick a Gauss meter between two large magnets, bring them together, there is no magnetism.
So he just said there's no magnetism, i.e., but frankly, there's plenty of force. It's just balanced, north against south. That's all. There's an equal amount, and equalities mean nothing happens. If I put a scale up and I put 3 pounds on one side and 3 pounds on the other side, the scale doesn't move.
The center of any magnet, if you're able to probe it, there is no magnetic field. There's no magnetic flux. At the center of a source of gravity.
So again, that's just a statement. There's no evidence that that's true in the sense that anybody could ever measure inside of a magnet, so that you can't do it. And clearly the magnet, you could argue that there's got to be more of something one side than the other side. So you're always going to have some tendency to go in one direction or the other. I would argue the right-hand rule kind of obliges there to be a bias.
Gravity, there is no gravity. So if you can go into a capsule...
So again, there's no gravity. There's no gravity if you want to use gravity as a description of movement. But if you understand that gravity as a force, well then you'll understand, or something caused by a field modality, that there's a balance in the fields. And that's why there's no gravity. It's not that there's no force, there's not that there's no fields, that there's just no imbalance in the fields. There's not more wind on one side than there is wind on the other side. There's plenty of wind. It's just pushing on both sides the same.
The Earth, of course, there'd be no gravity. At the center of an electrostatic, i.e. a dielectric field, there's the highest...
Just understand, the center means there's an equal amount of Earth on one side of you as there is on the other side, above you as there is below you. So it's like standing between two planets. There's a place between the Earth and the Moon where there's zero gravity. You know, the two completely balance. And you're not, if I place you there, you won't move towards the Earth or towards the Moon. You'll just stay there. That happens between any two clumps of mass.
Concentration is the same. So at the center of a magnet, there's no magnetism. At the center of a source of gravity, there is no gravity. But the center of a dielectric field and electricity, of course.
So again, there's a simple cause and effect explanation for that, right? And it just has to do with gravity is associated with mass, and there's an equal amount of mass on one side as there is the other side. Now, if I put that planet that you're in the middle of and I put it next to the sun, you're still going to be pulled towards the sun.
Is to be disregarded. Specifically, Charles Proteus Steinmetz specifically states in his book on page 8 of Electrical Discharges, Waves, and Impulses and other places that...
Let's understand, this is a guy 100 years ago. You know, before a ton of experiments, before, you know, automobiles, you know, Model A's. He was still, you know, this is a long, long time ago. And he wants to go even back further to find the truth. So when we had less evidence, less information is somehow more. And he thinks they drew better conclusions when they had less knowledge. And that's like saying that the Christians got it right, that diseases are caused by spirits, not microbes.
Even in his day, 100 years ago, almost 100 years exactly, everybody had no effing clue what dielectricity was versus electricity. Electricity, he said...
Yes, nobody has a clue then, nobody has a clue now. Everybody gave up on the word because it's not a concept. Electricity is a phenomenon that happens inside of conductors. There's just no such thing as dielectricity.
It specifically was 5 times psi equals Q in Planck of electrification.
So again, whatever that is, that mush, again, just absolute mush, can't make any sense out of it.
In other words, electricity is a hybrid of dielectricity. He actually said that scientists of his day, 100 years ago, have overtly complicated the understanding.
Right, so he invents a different kind of electricity for which there's no evidence of and creates some sort of hybrid that can't possibly be relevant because there's no way for us to ever to detect something called dielectricity or the distinction between something called electricity and dielectricity, and yet he's claiming they've complicated things. And this was the guy he points out who had mathematical formulas that drifted over pages and pages of a book and that were never converted into a solved solution. And you're going to say he's the guy who simplified things? Oh, I don't think so.
Of what electricity is versus electrostatics, i.e. dielectricity.
So again, i.e. electrostatics, again, it's electricity. Static electricity is electricity. It isn't some other thing. Electricity is a phenomenon. It's the flow of pressure between atoms. Conductive atoms.
Actually, when you understand what dielectricity is, explaining how an electromagnet works is incredibly simple.
Right, but he won't do that. It's not in this video.
I don't know if you know how like a giant electromagnet works, like when they actually pick up huge cars out in the junkyard. You know, where does the magnetism come? I mean, it actually feeds electricity into the coil, but, you know, why does it turn into, you know, what is the basis of a giant electromagnet?
Yes, well, what is the basis of a coil? That's the part that ought to kind of give it away to you people. Why does a coil matter? What does coiling the wire do? How does that magnify? And then you might be able to figure out that, oh, coils create internal reflections. Yeah, anything inside that would be radiated would end up reflecting back again, and then reflecting back again, and reflecting back again, Yeah, that's what a coil will do. It'll take all the energy. Say if you have a straight wire, all the energy just goes into space. But if you coil the wire, then a percentage of the energy will be saved, because all the energy coming off, the one side of the wire will stay and just keep adding up, multiplying like a mirror.
And the answer is that the electricity that's actually fed into that coil, into the electromagnet, the dielectricity is lost in counter space, and the only thing that...
So the dielectricity is lost in counter space, and some hybrid grows out of the seeds or something. I mean, he's not saying anything. How can people listen to this, reward this? He's not saying anything. And again, people keep making excuses. Well, he's a photography guy, and... Are photographers pathologically insane? I mean, what exactly is it? How do you get 674 likes for such a steaming pile of incomprehensible jargon? I mean, all I can see is the Homer Simpson effect. I mean, all I can see is people just identify with fat and underqualified. There's nothing else.
It remains. It is freed. Magnetism is freed from its dielectric counterpart in the electricity and X number of volts and watts. X number of volts and amps that are actually fed to that coil, depending on the size of the electromagnet. And what's left is a very powerful magnetic field.
And what's left? And was there any explanation for how it happens? None. Why does it happen? Why does it need a core? Why does a core make another huge difference? Putting a core in the coil. So, I mean, he doesn't explain any of it. Nothing's explained. I mean, I would explain it as that now your reflections are causing all of the iron to line up with the fields. And so all the atoms are being lined up like little magnets, and once you line them up, they become a big magnet. That's the only difference between a magnetized substance and a non-magnetized one, is the atoms are lined up in one and they're not lined up in the other. That's it. That's the difference. Does he say that? Does he talk about domains? And these are all things we physically have seen, in a sense that they've seen them essentially in crystals. This is a real thing that happens. The atoms changing position, and that causing them to become magnetic. Alright, this is enough, right? But yeah, I don't, this is why I said I hate this planet. I mean, how else are you going to, there's no explanation for this. This is just absolute gibberish. This is replacing Jesus with Mohammed. I mean, this is not an improvement. And, all you can say is, man, are people idiotic dupes? And they'll follow anything. They'll follow anything. Because he sits there and talks confidently, and then uses a couple of friendly little spirit words and, friendly love words, they'll buy anything. It's disgusting. I'm disgusted, revolted, disturbed. There's something seriously wrong on planet Earth that this works. This gibberish can work.